Alright, I'm just gonna move on. Alright, welcome back to test review day 2 for the third? Is this the third USEMO? Yeah, third USEMO! I totally know when my contests are. Oh, actually I should show all the problems first for the people that are just dropping in. So this is day 2. Looks like this. Geo 4, Algebra 5, and Combo 6 with bagels. No Halloween flavor text, sadly. I didn't find any problems on this day that I could shoehorn random Halloween text into. Why do we have 2 out today? I don't know. Okay, let's do the geo. So in this geo, you have a triangle ABC. And you have a reflection here, so that's X. Okay, let me move this to the right place. Okay, we get it. You can bash geo. Number 4 is like very cool. There's a circle, I guess. Alright, cool. Cool, and then BD intersect AC is something, so I'm just gonna draw this, like, kind of roughly. So here is E, and there's F. And I have this circle here through M and N. And the question is, can line MN meet in line EF? So I know a lot of you want to use Brocard's theorem, and indeed there are solutions that use that. We're not going to use it here because this is the PG-13 version of the solution. So what I'm going to do is I'm going to let P be this midpoint here. Well, basically, so I take a homothenity from the blue circle to the red circle, right? And it gives me this midline here. So here's the midpoint of AD. It lies on the red circle and on line BN. Okay, so we first note that this angle this angle here, because of the parallel lines, is equal to this angle here, is equal to this angle here. Also, there's more equal angles. Where does it go? Where'd it go? This angle here is, again, because the parallel lines equal to this angle here. I'm gonna get this wrong. Equal to this angle here. So 3 sets of equal angles. Sorry, 2 sets. So the first angle set tells you that something is equal to something. Let's see. FP times FA equals FB squared from the yellow angles. The green angles tell you that EN times EA equals EB squared. So therefore, EF is the radical axis of AMN and B. And we're done! Yeah, so if you're wondering why this problem made the test, now you know. Because like I think what happened is like a lot of the strong test solvers are just like, wait, I can just like use Brocard and invert or something, and we're just like confused why this was an easy problem. And then I showed them the solution, and now they were like, oh, I get, okay, that's fine. So I think the guy's name is actually spelled with a C. And it's spelled that way in my textbook, and then everywhere else I spell it with a K because that's what I've seen. Yeah, no, that's a whole solution. Like Like E and F have equal power because of the angles, the end. So other ways that you can do this are, for example, if you don't want to use any angles at all, what you can do is the following. Now we're going to do the high part solution. Shout out to Amogus Sus Yu. But yeah, so this line EF, it passes through the harmonic conjugate of x with respect to AB, and because B is the midpoint of AX, this point is like in a 1:2 ratio here. So this point lies on the radical axis by computation, and also the center of this circle is perpendicular to this line because OX, if I draw an O, let me use a different color. OX is perpendicular also by Brocart's theorem, so this line here is also perpendicular. So that gives you a way to show EF is the radical axis without touching the points E or F, because it's the polar of the point X and passes through the harmonic conjugate of X with respect to AB. Oh, O needs to be on the circle? Good point. Yeah. O. Alright. Yeah. I agree O is on the circle. Yeah, I think the correct thing to do is just big point this thing. Just like... Yeah, well, now the diagrams do scale. Alright, cool. Moving on to problem 5. So... there's a politically correct solution using roots of unity, because of course it does. But, like, let's be real. SP is the integral of 1 over 2 pi, 0 to 2 pi of absolute value P of e to the ix squared dx. Oh, there's some lag. So you're done by Kochi. Yeah, so this is like the nice way to write it up. Of course, we wouldn't put this on the contest if you couldn't make the solution slightly more convoluted by instead using a roots of unity filter, where you sum from k equals 0 to n minus 1 of p of e to the 2 pi I k over n squared for n greater than the max of the degree g. So the second identity is also true and also implies the problem by Cauchy sorts, but like the only difference is that like one of them doesn't use an integral, and one of them is way more natural. So take a pick. Yeah, so yeah. Yeah, as SP is given by this, yeah. Yes. Yes, if you complex bash P4, you use complex numbers for the wrong problem. Okay, let's do problem 6. Are there any other solutions? I'm not aware of any solution that isn't basically this. However, I also won't be surprised if someone finds a different way to do it. But so far we don't know. I'm not currently aware of any other solution. As I say that, let me check AOPS to see if anyone came up with anything different. Yeah, I feel like I get like super good problems for the USEMO, like better problems than I get for like USEMO, which is I guess a thing that can happen. Okay, someone has a claim about using Lagrange interpolation. I feel like this is actually a more confusing way of writing the same thing, but it doesn't look wrong. Wait, did no one type up the bagel yet? Wait, is the bagel not up yet? I don't see the bagel. Yeah, it's 3 house. Oh, never mind. The bagel is here. Cross your fingers, that the problem captain is really nice. I forgot who the captain for this problem is. Oh wait, that's the wrong string. That's the Hanabi view. We want the whiteboard. Yeah, I feel like construction may get a point. I think either direction can get a point, honestly. Alright, so, I guess I'll first tell you what the construction is, right? So what we're going to do is, thank you Millie Way for the follow. So basically what you do is, let me say, let D be a set of integers, which I'm going to call a ruler for reasons that will be clear momentarily. And then what I do is I construct D by D. So each of these lines that I'm drawing is a 1 by D array of cells. So actually, let's give an example of a ruler. Does anyone know the perfect column ruler off their head? I'll just... perfect column ruler. Oh, there isn't one. Okay, no, it doesn't matter. Let's say like 0, 1, 4, 6 as an example. So I'm gonna just do a 4x4 example. Okay, this grid's too big. Ah! Try again. So it looks like this. And the reason this is called a ruler is because in D, I can measure any length between... is it Galoom? Galoom. I don't know, I just... So for example, if I want a bagel that is like 5 wide and 3 tall, here it is. So that's a bagel in my ruler. Oh, let me highlight it. I think it's easier to see that way. Bagel. Okay, so yeah, so basically I'm going to construct a ruler D such that I can measure all the lanes from 0 to n. And there is interesting theory about like how good you can get these rulers to be. But for this problem, because we get to pick the constant, we don't have to try very hard. So the idea is I'm going to pick a ruler of the following shape. 0, 1, 2, up to L minus 1. And 0, minus L, minus 2L, up to minus like L squared-ish. So this is a pretty dumb ruler. It's like there's a part of the ruler that lets you measure like the remainder mod L, and then the other punk is just like a normal ruler scaled up by L. So this ruler, as long as I rig it so that L is, I think, like about 2 root n, it should be good enough. And then this construction will get about like n to the 3 halves times some constant. So that's a construction. Basically the idea is you want to do the 1D version of the problem where you just want a ruler. And it's hard to figure out what the optimal ruler is, but you don't need an optimal ruler. You just need any ruler that isn't terrible. So, okay. A ruler is like, you imagine you have like a piece of wood and there's like certain marks on the wood. For example, let me actually draw this for D equals 3. L equals, no, let's do like 5. So this is a piece of wood, and there's a mark at 0, 1, 2, 3, 4, and then -5, -10, -15, -20. So if I want, this ruler lets me measure a segment of length 17, for example. Like here's, everyone's favorite random number is 17. Shoot. 17. So that's what a ruler is. It is a set of marks such that you can measure any length between, let's say, 0 and n. That's good enough. And if you take a ruler and then build a construction like this, then this will let you build any bagel, because you just... In fact, it lets you build an AB bagel for any a and b less than or equal to n. So that's a ruler. Okay, so the bound is actually shorter than this. The bound is actually easier to write up than the construction with the ruler. Actually, let me do it side by side for contrast. What I'm going to do is, suppose I have a bakery S. And then for every bagel that's in here, every bagel, let's say, has a long and a short... long segment and a short segment. Alright? So, long, short. So, some of them are horizontal and some of them are vertical. Ba 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 da da da. Hang on. Oh, yeah, okay. So, let's say without loss of generality, at least half the bagels are horizontal. So their long end runs parallel to the x-axis. Square, you can pick whichever one you want to be long or short. It doesn't matter. Yeah, so if a square is both, I don't really care. So now in this grid, let's say in bakery S, row is fat if used in a horizontal. As the horizontal leg of a bagel. So, you have your set S, and then in your set S, there's a bagel somewhere that I guess I should highlight. So, this one is fat, this one is fat. Fat, fat. Okay, so, on the one hand, the number of fat things choose 2 has to be at least like n over 8. Because there are bagels, for every distance from 1 to, there's bagels whose short side is length n over 8. On the other hand, each fat row has at least like n over 4 cells. Because that's how many cells are in the bagel. Okay, so now you put these together and you get f of n is at least like n to the 3/2. Because this thing will tell you the number of fat is like roughly root n over 2. Let me say like at least and floor or something. So this will get you a bound of like n to the 3/2 over 8. Yeah, so definitely it's a problem where if you know how to do one direction, it helps you a lot for the other. Because you look at this and it's like, oh, there's just fat rows corresponding to long ends of the bagels. So as long I have enough fat rows and the fat rows have enough cells, and that's the lower bound. All right. That concludes test review. Wait, if no one's posted the solution yet, I will put it on the forum just so that it's there. Oh my god, there's so many duplicate threads already. I think next year I'm just gonna say I get to post the thread so I don't have to figure out which thread came first, because it's really annoying. Alright. Oh my god, that white... Why does ALS put everything in display style? Jesus! Okay, yeah, this is for pedagogical value, because like people probably... Not everyone's watching this stream, but I think a lot of people are watching ALS for the solutions. So I'll put this up. Alright, I was gonna text style this cage. I know. I think I said root 2 times root n on the stream when I should have said like 1/2, but no one... The constants don't matter because 100 is generous enough that I don't think anyone should have problems getting within 100, even if you screw up a couple times. Oh no. There's like... $35, $30... Oh, I can't even tell which one was first because they all came at like exactly the same... This is such a silly system. Okay, you know what? Some other moderator can deal with it. I don't have the patience to figure out which thread came first by repeatedly refreshing until I can get them to differ by like a second or so. It's beyond my ability. Oh, if I replace dollar with... Oh, that's good to know. Okay. Okay, that's good to know. You can look at that. Oh, that's smart. The IDs come in increasing order. Okay, I still don't care enough. No, actually, I should consolidate all of them. This is such a stupid job. Can you check my probable fake solve? Maybe. It will probably get looked at because it's like a problem for which there aren't many claims to other solutions. Literally 3 consecutive posts. But yeah, I think actually, okay, I will actually look at it now because I'm curious what this is. Dun, 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 dun. Okay, you claim they're okay. Okay. Wait, this is the right vibe. What is AI? Oh, that's just multiplication. Okay, so let's just could solve for. Okay, so every coefficient is non-negative linear. Alright, hang on. Yes, I agree that every coefficient is a linear combination of the FIs. You can do this also by Newton's formula. I think might be an easier way to see it, where every polynomial with integer every polynomial of degree n is determined by its values at 0 through n minus, 1 through n or whatever, which is like a certain sum of binomial coefficients times like the values, some finite difference of the values. Actually, that might be harder to see. Anyways, I agree that they're linear. Okay. Yeah, this is fine. This works. Oh wait, am I worried about negative stuff? No. Cauchy in this form holds for all real numbers, right? No, I don't think this Cauchy sort should hang on. Crap. No, you might be right. Shit. Alright, I can't see this without paper. Plug that for using the fact that so this is true because is this C a different than B? Is C supposed to be B here? It doesn't matter. Yeah, no, this way is. Yeah, they're reported for being duplicates, so eventually someone will mark it as resolved or something or other. Oh man, this idea is so cute though. It's basically like it's trying to do the roots of unity thing without the observation that it happens to be the roots of unity. It's the claim is that you should be able to do this with any set of input values. The problem is that BIGA is indeed probably mixed sign. Ah no. Oh no, I really wanted this to work. Yeah, okay. No, I don't know if this would have exists. The reason the roots of unity thing works so well is because the thing that's being summed over is that you throw into Cauchy is explicitly non-negative. This one may not work with. But can I get the BIJs to be non-negative? Because you can actually pick the. Maybe not with 0 through k, but you can pick the input values in terms of the polynomials. It's like you look at the polynomials and you pick some input values for which you think those coefficients are going to be non-negative. No, I don't think you can always get a non-negative. Oh, that's rough. Is this just supposed to be Parseval's theorem? Or whatever? Oh, maybe? I forget how that theorem goes. Okay, I remember how that theorem goes. Yeah, I guess it's Parseval's theorem. Lamau. Yeah, okay, I agree. Yeah, okay. Can FE? Sure. Yes, there is no FE. Yada 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 yada. I mean, I assume if you think you solved this, it's probably fine. Like, I don't see how you would mess this up with the correct solution. Shrug. No, yeah, this problem has a lot of solutions. I think problem 1 and problem 4 are both going to be like really intense to grid. I'm not looking forward to it. The problem 1 is the one where people will write a lot of words and like not really be clear about what they're trying to say. And problem 4 is going to be there are like a billion distinct solutions, and then you just have to read all of them. All of these, I think a lot of the synthetic solutions have the same idea that you want, like, the radical axis, and then one of them doesn't, and it's called use Brocard, invert, and coordinate mesh, which is arguably, if you know all the fancy stuff, arguably is the most straightforward. Because you're just like, well, and I'm going to invert this, and it'll be the circle with diameter OX. And I'm going to invert this, and it'll be the tangent at A. So it's literally saying, like, can a circle through, I don't know, something hit that tangent line? And the answer is no, because you let A be 1, 0. And coordinate mesh. Yeah. Not literally a billion. A lot. There's a lot. Alright. Hope you had fun. Scores will be out eventually, depending on how diligent my graders are. If you're not from the US, and you still want to help grade, please come through. I was actually really reluctant to put problem 1 on the test because I was like, I really don't want to grade this. And then people convinced me that it's more important to pick the problems people like the best than the problems that are easiest for the graders. So, yeah. Can I volunteer? No, sorry. If you took the test, you are not invited to grade. Because I want to have a semblance of a serious contest, even though it's obviously a joke. Shout out to ASDF334 for being an ORZ prodigy. That's from Tokas619. Amazing. yeah. Okay, so we have yet another game from our sponsors, if I can find it. Why didn't anything happen? Play. I thought I checked this. Oh no. Wait, I tested this before and it launched fine. Why won't it launch now? No! Oh, I think I know what the issue is. Right. I actually had this issue before. Pray in the Gloria Segro to launch the Steam game. Made with Unity. What are your recommendations for learning Olympiad algebra? I don't know if I have anything in particular. I literally tested this before to make sure it worked. Oh, there you go. Alright. But that was chaos. Well, at least I got things back working in